All right, 8th grade math. This is a pretty exciting topic. It's going to be a little bit different than what we've been doing. So if you're working ahead and you haven't taken your quiz yet over the first 2 sections, you do need to be able to do that on the quiz. You can use this new method to check that you did it right, but you do need to be able to draw squares tilted, find the areas of them, and the side length using dot paper. But this is so cool. You're going to get excited. So this is where we are in your packet, problem 3.1, and this says discovering the Pythagorean theorem. I'm going to click back and forth between this lovely grid that we're going to fill out together and this interactive thing. So the first question in your grid says a red leg of 1 and a blue leg of 1. So, can I go right here? That's what you're looking at. Now, if you count the area of the red square, this is a square of 1. And if you count the area of the blue square, the area is 1. And if you count the area of the yellow square, each of these are a half. That's kind of why it's broken up like that. So this area is 2. So I'm going to go back and fill that out on this. So the red square was 1. The blue square was also 1, and then the yellow square had an area of 2. And what that means is that the square root of 2 is the side length, which we already know is 1.414. So this side length right here, and every side length, is the square root of 2. Cool. Okay. The next one on the grid is a 1 by 2. So the red square's area, if you look at it, is 1. And the blue square's area now is 4, because 2 times 2 is 4. And then if you look at the yellow, remember area of a square, base times height, so that's 1. And then these triangles are all 2 by 1. So 2 times 1 is 2, divided by 2 is 1. When you have a triangle, you divide by 2. So the area of the yellow square is 5, which means this side length is the square root of 5. So we're going to fill that out on your grid. So the area of the red square was 1. The area of the blue square was 4. The area of the tilted yellow square was 5. And then the square root of 5. And if you pull up your calculator, the square root of 5 as a decimal. So to get the square root, you're doing second x squared. Or you could do math. I think there's a square root under there too. 2.236. Great. The next one on your grid is a 2 by 2. So the area of the red square is 4. The blue square is still 4, because 2 times 2 is 4. And then if you look at the yellow, this is broken up into 4 triangles, and they're all 2 by 2. So the area of a triangle, base times height divided by 2. 2 times 2 is 4, divided by 2 is 2. So each of these triangles are 2, therefore the yellow square has an area of 8, which means the side length has a length of the square root of 8. And you really should put units squared and units. So, red square, area 4. Blue square, area 4. Yellow square, area of 8. Square root of 8. Calculator. And we're knowing this is just below 3 because square root of 9 is 3. So 2.828. Okay, the next one, a 1 by 3. So in a 1 by 3, the red square's area is 1. The blue square's area is a 3 by 3, which is 9. See how there's 9 squares in there? And then we have our yellow business. It's already broken up. The inner box here is 4. Each of these triangles are 3 by 1. That means they're 1.5, because 3 times 1 is 3, divided by 2 is 1.5. So 4, 5, 6, 7, 8, 9, 10. So the yellow tilted square's area is 10, which means that this side length and every single side length that drops to give you a 3 by 1 triangle, all of these side lengths our square root of 10. And if you want to put units squared on the area, just so you know, that's a beautiful thing. Alrighty, so 1, 9, 10, square root of 10. And for the decimal, since the square root of 9 is 3, hopefully you're figuring out that the square root of 10 is probably 3.1-ish because it's just above 9. 3.162. Excellent. This is so enjoyable. Next on your grid, you have a 2 by 3. So, if you look at this lovely picture, the red square's area is 4. The blue square's area is 9. The yellow square in the middle is 1. All of the triangles are the same. They are 3 by 2s. 3 times 2 is 6, divided by 2 is 3. Each of these triangles is 3. 3, 6, 9, 12. The yellow square's area is 13 units squared. And what that means is every single diagonal length, every single side of this square is the square root of 13. And we know that the square root of 9 is 3, and the square root of 16 is 4. So the square root of 13, I'm going to guess, is 3 point, you make a guess. We'll see how close we are. Red square, 4. Blue square, 9. Total, 13. Maybe you're noticing a pattern. .606. Doesn't it feel great how close we were? You should just sit back and smile right now. All right, next up, we have a 3 by 3. If you're noticing a pattern, maybe see if you can just fill it out before I even get it done. It's like a race right now. Very exciting. Red square, 3 by 3, 9. Blue square, 3 by 3, 9. Yellow square. If you have the pattern, go ahead and fill it out. This yellow square is broken up into 3 of the same triangles. These triangles are 3 by 3s. 3 times 3 is 9, divided by 2 is 4.5. So each of these triangles are 4.5. 2 4.5s is 9, so 4 4.5s is 18. 18 units squared is the area, which means every single side length is the square root of 18. Every single one of these. Anytime you have a side length where it drops to give you a 3 by 3 triangle, it's the square root of 18. Square root of 18. We know the square root of 16 is 4. We know the square root of 25 is 5. The square root of 18 is hanging out right here. Let's guess. It's so fun. That's my guess. Let's see where we are. Red square, 9. Blue square, 9. Yellow square, 18. Feeling so blessed that we have calculators right on our devices that can do all of this. What a wonderful thing. This is great. 4.2426. Look at that. Are you feeling great? If not, you should be. This is so doable. You can do this. We've got 2 more. Red 3, blue 4. A 3 by 3 is 9. You can either count up the squares in the blue, or you can do a 4 by 4, which is 16. Here goes the yellow. We've got that square in the middle. Each of these triangles are 4 by 3. Same exact thing as what we have initially. So 4 times 3 is 12, divided by 2 is 6. These are each 6. 4 6s is 24, plus 1 is 25. The area is 25 units squared. That means the side length is the square root of 25. Now 25 is special. It's special because it's a perfect square root. So the square root of 25 is 5. So we don't even need the calculator for this one. Red square's area, 9. Blue squares area, 16. Yellow squares area, 25. Are you noticing a pattern? Okay, the grand finale. 4 by 6. We're jumping. You might know the pattern. If you do, try it. Red squares area, 16. 4 times 4. Blue squares area, 6 times 6, 36. Yellow squares area, the middle's 4. These are 4 by 6 triangles. 4 times 6 is 24. Divided by 2 is 12. Holy announcement. I don't know if you can hear that. Okay. So, the yellow squares area is 52, which means each side length is the square root of 52. Square root of 52. Square root of 25 is 5. Square root of, I don't know why I'm so low, is 6. Let's keep going. Square root of 49 is 7. Square root of 84, or, oh my goodness, 64 is 8. 52, bam, right here. Let's guess. It's like winning the lottery. That's my guess. Okay, filling it out. Red squares area, 16. Blue squares area, 36. You get the yellow squares area, which is 52. And the square root of 52 in your calculator. I think it's probably going to be lower than what I put. 7.211. Pretty darn close. Now, maybe you found the pattern. Maybe you didn't. But right now, you're going to look at the red and the blue, and then you're going to look at the black in each row and see if you see what I see. Because you can see that the red plus the blue will always equal the yellow tilted square. So what this means is that the two smaller squares add to give you the tilted square. So what this means is that after your quiz, you don't have to necessarily draw the tilted squares, because if you can draw a square off of each leg, you know that this red square, whoa, red doesn't work on red, and that this blue square, if you cut them up into pieces, they will perfectly fit into this yellow square, because the red squares area plus the blue squares area is always the yellow squares area. That is the Pythagorean theorem. That is what this dude called Pythagoras founded many years ago. And because of him, we can always find this lovely hypotenuse, which is so useful in so many things in life, especially building. So, the two legs of a right triangle. Okay, so the two legs of the right triangle. Here's the right angle. This is called the hypotenuse. This is leg 1. This was like the red square, and this was the blue square. I don't know why it's not blue. So the two legs of a right triangle, if you square each number and add them together, you will get the tilted squares area. The length of the hypotenuse is the square root of that area. That is so huge. So this square, let's just say this is a 5 by 6. So this square's area, 25, plus this square's area, 36, will give you this square's area, 25, plus 36 is 61. Once you know this square's area, you know that the side length is the square root of that area. Pythagorean theorem. Hope you enjoyed.